There we go. Cool. And I can send this to you after.
Cool.
Yeah. So 2 or 3 years ago, people started to gradually worry a little bit more about open source security and supply chain security. And so I went actually over to out of the Google Cloud organization over to the core security team at Google.
Mhm.
So just responsible for that kind of infrastructure. Um, just securing Google from bad things happening, not selling products or anything like that. And that was going great. Pandemic slowed a bunch of stuff down. We were trying to work with people like GitLab and GitHub and all these other companies to do basic stuff like turn on two-factor auth for NPM, which they finally did years later,
Right.
kind of stuff. And just a little slow, pandemic, blah, blah, blah. And then all of a sudden SolarWinds happened about a year ago. And everybody was like,
Mhm.
wait, this is crazy. Why is nobody even paying attention to this? We got to go solve this problem. And so some of the other open source projects that we'd started like just took off overnight almost after SolarWinds.
Yeah.
In particular, SIG Store, I think, which is kind of how we started chatting.
Yeah.
Yeah, SIG Store.
And to be clear, like SIG Store is like, as far as I can tell, more of like an umbrella
Mhm.
like organization,
Yeah.
right? That's really maintaining stuff like Wrecker and Cosign, and there's another one.
Yeah, the certificate authority part is full CO, I think. Yeah.
Okay, yeah, but
Yeah.
then like Spiffy is and Inspire are still maintained by. I don't. I'm not familiar with those folks,
Mhm.
but that's been a project that you guys are just sort of leveraging, right? But aren't directly
Yeah.
responsible for.
Yeah, so Spiffy and Spire they're two separate. Yeah, they're two other open source projects. Spiffy is a specification that anybody can implement, and then Spire is like a reference implementation-y kind of thing.
Right.
Yeah,
Right.
and so we use the specification and stuff.
And is my memory correct that the I think Spiffy like was like primarily motivated by Istio, is that right? Or at least like service mesh in general?
I think that's where it's seeing most of its usage. I don't remember the exact history.
Uh-huh.
Joe Beta wrote the original paper after he left Google,
Okay.
and he went over to start Heptio instead of working more on it. So I think somebody else
Gotcha.
kind of took his white paper and ran with it, something like that. Um, yeah, so SIG Store we started in late 2020, something like that. People from Red Hat were playing with transparency logs and that kind of thing. You remember Brandon Phillips? Does that name ring a bell? He was the founder of CoreOS.
I mean, it sounds familiar, but I can't place it. Yeah.
So yeah, sometime after the CoreOS got acquired, he wrote a tool called rget. It's kind of hard to find now; it's kind of gone from GitHub
Hmm.
and everything. But it was kind of doing transparency logs for downloads to try to improve like curl pipe to bash in
Hmm.
those use cases. And he had some cool ideas, like he was using normal certificate authorities and certificate logs to do it, so he didn't have to run any infrastructure, and it was some cool hacks. But eventually, the people running web certificate transparency asked him to please not do that because it's not really what it's for, and it was kind of an abuse, so he turned it down.
Right.
So a lot of the SIG Store stuff was like setting up a separate set of infrastructures so we can kind of do those things again and play with it.
Right.
But the basic idea was trying to copy Let's Encrypt if you played around with that much. So
Yeah.
if you remember what the internet was like before Let's Encrypt, it was really hard to get certificates. Nobody really
I'm
did it.
actually appropriately
Oh, awesome.
representing.
Nice.
Yeah.
I was just clipped.
Yeah.
Um, yeah, so it's kind of hard to get certificates. You had to pay somebody. It was all email based. You'd get them for 2 years, forget every single time. The certs would expire, blah, blah, blah. And then
Hmm.
Let's Encrypt came, made the Acme specification, that kind of thing, automated it all, did it for free. And now the whole internet is encrypting because they made
Yeah.
it, easy enough to do by default. So that's great. So we spent a while looking at different open source communities and why nobody was signing stuff. And it's like you always could sign stuff, but nobody was really doing it. And PGP keys suck and they're hard to manage and it's hard
Right.
to verify and all that stuff. And then were code signing certificate authorities. You can pay a bunch of money, get some certificates, that kind of thing.
Right.
But nobody does that. I'm like, well, what if we do that except for like do what Let's Encrypt did to that market?
Hmm.
So for code signing, so we set up all this infrastructure for free code signing certs and tools to get them automatically. So you don't even have to think about it. You don't have to manage keys. You just click the login button and get stuff. And so that's going pretty well, especially after SolarWinds. Everybody wanted to start signing everything,
Right.
especially containers and all that stuff. So that was going pretty well, but it was set up like Let's Encrypt, public benefit. The infrastructure is run by the Linux Foundation, the same group that Let's Encrypt is kind of housed under.
Right.
Um, my team was doing a bunch of other open source stuff, open source security things, and after SolarWinds, a bunch of companies just started reaching out for help, and they're like, "Oh, you're signing stuff for open source. We need to sign our internal stuff. Can you help? We need
Hmm.
all this help." And we're kind of helping companies. Actually, SolarWinds in particular was a funny case where their CEO testified to Congress a bunch of times about how they were going to fix everything and build this crazy secure build system with 3 different systems on 3 different clouds, comparing hashes at every step of the way, so nothing bad could ever happen again.
Right.
So we got to help them on some of that because they're using Tecton, and they found all the work that we had done there and kind of put it all together.
And it's similar to how the distro list images are built and
Yep.
produced, and I think even they're even built in multiple separate
Yeah.
systems and the hashes compared, right?
Yep.
Yeah.
Yeah. That was another fun one, or we'd started the distroless project just as like a joke to see if you could build containers with Bazel and that kind of thing. And it was just there in GitHub, and then randomly Kubernetes switched all of their images over to distroless without telling anybody, and so they became like a critical component of open source security overnight without anybody meaning to. So then we spent a
Right.
while trying to secure that stuff.
Right.
Um, yeah, after working with SolarWinds, they actually gave an amazing talk, which is up on YouTube now. If you haven't seen it yet,
Oh,
at
cool.
KubeCon, of the build system they designed, all of it. It's great.
And it's
Um,
based on SIG Store tooling now.
SIG Store and Tecton and all of that stuff. Yeah,
Very cool.
so
Sweet.
it's a really good talk that gets into it. Um, And after doing that enough times, we weren't even in a product group at Google anymore. We were just doing this for like open source and trying to improve that. I was like, well, somebody's going to start a company here. We just helped like 5 different companies build these internal systems. We should just go try to start that company.
Uh-huh.
So
Yeah,
not
makes
really
sense.
competing with what we were doing at Google. To kind of answer your question, like why didn't we think we could do it there? It was just like we weren't in a product group. We weren't selling anything. It was just to try to
Hmm.
improve stuff. But somebody's going to figure out a product. So maybe I should go try that. It's kind of the real motivation.
Yeah, yeah, makes sense.
Mhm.
And I think the I just recently
Yeah.
stumbled across your zero trust supply chain security
Mhm.
talk.
Oh yeah.
I think
There's a blog post too somewhere I wrote that might be a little more digestible if people don't want to watch the video.
yeah, I think I've seen that too. So I watched the talk, and I think it is like probably the most like comprehensive overview of like where things are at. I think you did a great job of like walking through the individual components, why each component is necessary,
Mhm.
and like really highlighting like the sheer number of entry points that are like possible attack vectors, right? Because I think people don't really appreciate that like it's not like we have to solve this problem for like one step of the pipeline. It's
Yeah.
literally every step is potentially vulnerable. Um, but like
Yeah, every time
I
something
think
like
everybody's take
Log4j happens, people realize how much stuff there is and how many people they're relying on that they
yeah,
don't
and
even
how
think of.
difficult it can be to even investigate like
Right.
where you're vulnerable, right?
Yeah.
Um, but like I think a lot of people's takeaway would be like, okay, great, so I'm vulnerable, right? But this
Yeah.
still sounds really hard to set up and implement at my
Yeah. Oh yeah.
organization, right? And certainly that was my experience at NASA. It was just like, yeah, we know how we can tie these tool chains together on a like project
Yeah.
by project basis, but like how do we do it at the scale of an organization?
Oh yeah. It's not
And that
easy.
was
Yeah.
yeah, exactly. And that was sort of like my we were building a platform on top of GitLab and Kubernetes at NASA, and that was like one of my key motivations for wanting to join the GitLab team was that like this stuff is still too hard, right? Nobody's going to do it if it's hard.
Yep.
In the same way that like nobody's going to uh, we're not going to get HTTPS enabled everywhere unless something like Let's
Yeah.
Encrypt exists, right? And so
Just yelling at
like
people to do it right is not a good long-term strategy.
yeah. So I guess like do
Yeah.
you think the problem is still educating folks, or do you think the problem is just maturing the tooling and making it easier to use?
Definitely. I mean, I'm always a believer. Like, we just have to make it easy. We have to make it on by default. People have to not even think about it. Otherwise, it just won't work. I
Right.
think there's some education to do or more around awareness, like so people even acknowledge that it's or are aware it's a problem. I think that's
Mhm.
happening. I don't think we have to do that. I think the attackers are doing a great job of it.
Right.
I mean, so thankfully in some ways, not thankfully in other ways.
Right.
But yeah, like this isn't going to slow down supply chain attacks anytime soon. So it's happening slower than it should be. Um, I don't remember if I mentioned in that talk, but yeah, it's like, I mean, we've known about this as an issue since like the early 80s when Ken Thompson wrote that paper, if you've seen it, Reflections on Trusting Trust.
I haven't seen that one.
Amazing paper, yeah, from early 80s, where he backdoored a compiler, just to mess with everybody at Bell Labs, if you remember that whole history at all.
Yeah.
And the compiler would insert a backdoor in every binary it built, and then everybody was, he even like, and then he even made it so if it was compiling another compiler, it would put that backdoor back in that compiler, so he could like delete the original backdoor and everything like that, and it would self-propagate forever.
Right.
And all these Bell Labs people were trying to find it, and he was also clever enough to like put a backdoor in it to, if it was compiling a disassembler, to hide the backdoor. So
Mm-hmm.
all the disassemblers that he compiled would even hide those backdoors, and so nobody could find anything. And so we knew
Yeah.
about this
Yeah.
in the 80s, how terrible it was if you don't trust, the entire universe of things that have compiled your code. But then everybody just
Right.
kind of forgot about it because it was like
And,
insurmountable and so terrifying.
and I think that like you did, if you didn't mention that explicitly, you
Yeah.
had mentioned it by analogy in that talk where you reference like a hypothetical of you use the vulnerable version of the Go compiler, right,
Yeah.
to build your code.
Right.
And I think that this is like a big thing that doesn't even cross people's minds, right?
Yeah.
That you not only like people think that like I've scanned my container image, I found no CVEs, I'm good to go, right? I don't think anybody like
Yeah.
even considers that like we have to verify the integrity of the things that built our software, not
Yeah.
just the outcome, right? Not
I'd
just the
love to
result.
show how
In
easy it is
fact,
to trick those scanners. Yeah.
exactly, yeah, but like, and we're not even like verifying the integrity of the scanners themselves, right? Let
Yeah.
alone the compiler.
Yep.
And so it's such a more complicated problem than it seems to be on the surface. Like
Yeah.
when people talk about software supply chain security, I think to 95% of people right now, that means that I've run a scan and it passed
Yeah.
clean, right?
Yep.
And like not to mention continuous monitoring, right? Like what happens when the CVE database gets updated? Like where's my inventory of all my containers that are currently deployed?
Yeah, my pet peeve is seeing those stupid DevOps pipelines where they throw a scan step right after the build. It's like, yeah, that is the wrong time to be doing it, and like it's not
Right.
a bad thing, but if you put it there, most people don't put it anywhere else, and it's like,
Right.
yep, you built an updated thing with the fresh version of Debian. I'd hope there are no CVEs in there.
Yeah.
It's later that they pop up, and
Right.
yeah, nobody thinks that. Oh, I mean, not nobody, but yeah, most of those stupid things like, oh, we security scanned it right after we built it, are missing the point entirely.
Totally. Yeah. And I think like just the marketing around all this
Yeah.
stuff, I think gives people a false sense of security. And I if I'm being completely honest, I think we're just as guilty of that at GitLab, right? Because we say that we have an end-to-end, like some level of an end-to-end software supply chain solution, but there's definitely like implicit trust that virtually every step of that, the developer's machine could be compromised.
Yep.
There's nothing we do about that. All the images that, I mean, we have a container-based pipeline system similar to Tecton, but every single one of those steps is potentially vulnerable too. So yeah, that was a big thing I wanted to get out of this call, was just to raise awareness that there's really no products in the market right now that are really like filling this gap end to end, like with a polished developer experience. That being said, I think like GitLab is uniquely positioned to potentially be able to do something like that, right? Because we certainly aim to be like an end-to-end DevSecOps solution. And as a result of that, we already have customers that are engaged with us from point A to point B through the software delivery process. And so to me, I see it as an opportunity, right? I see it as like we could really be a market leader in this space, and the tooling exists, and like we really just need to start looking at what the integration points look like,
Yeah. I mean, anybody that owns the whole cycle from the source code repository to the production environment is in a great spot here.
Yeah, and I really like I think what GitHub has done recently with like injecting OIDC tokens into their pipelines, like that are unique to that build. It's funny because like I had brought up in like an issue randomly, like, hey, we should like really consider like leaning into this like federated model that cloud providers are starting to support in terms of like not being able to not having to hard code credentials into your pipelines to be able to access cloud provider resources, but like being able to do that based on user identity in the tool is really cool. Like we should look at doing that. And then like 2 days later, the blog post from GitHub comes out about how they're doing exactly that, right?
You have tokens, I think. I saw it somewhere in the GitLab documentation. We couldn't use them directly with SIG Store. I can't remember the reason, but there's some product where you can get like an OIDC token and an environment variable with GitLab.
Is that right? I know we have like CI job tokens.
Yeah, there's like a. I'd have to find again. We have an issue open somewhere on.
Yeah, definitely link me because like I think I'd like to push on that.
We had a couple missing pieces. Go. Yeah, here's the one issue. What I had heard, and I don't know if this is true or not, but I've heard all of these SaaS providers are now starting to crank out OIDC support pretty quickly. Because Amazon, and this is the part I haven't confirmed because I never saw it, but yeah, Amazon is now starting to require it for any of their partners, like to start supporting authenticating to Amazon with the OIDC stuff rather than long-lived tokens. Just because so many of those tokens are getting leaked, it's their way of like pushing on everybody to start supporting the federated models.
Yeah, that makes a lot of sense.
So, yeah, because there were like 3 companies that all started doing it at the same time, and somebody told me, I can't remember why, somebody was like, yeah, we have to do this because Amazon told us we have to, otherwise we'll get removed from the partner marketplace by some date.
Yeah.
So.
Well, I mean, good for them. I think, to be fair though, to like Google's credit, I think they were the first to like provide federated workload identity, something like that. It's
been around for a while, yeah, especially in the GKE integration. It's really awesome.
Yeah, and like Google has been really like a pioneer from this space from the beginning. I feel like binary authorization was the first sort of like relatively easy to use example of like this sort of model, and like at the time it just like totally blew my mind. Like you described like what like scared you straight, I guess, for lack of a better phrase. Seeing like binary authorization, like the implementation is what got me to be like, wow, like this, everything we've ever done is not in any way secure, right?
Yeah, and even like even in Google, the solution that Google had internally was awesome, but it kind of relied on some of the fundamental assumptions of the Google environment, mostly that there was a mono repo that all code was in and everything was built from source in that mono repo. Even third-party dependencies would be checked in from source and built using the same build system to get like, see, there's really only one build step from source to production artifact at Google. And you only need to know the commit it was built at to determine the entire state of the universe roughly. And so that makes a lot of the stuff very easy because you don't need to track like chains of provenance and intermediate artifacts and stuff like that. So a lot of the tooling, a lot of stuff we're trying to do is like get those same security guarantees in production and same developer usability, but you can't just copy paste the Google implementation because it doesn't work when you have microservices and small repos that build things to intermediate artifacts and everything.
Yeah. And at the end of the day, it's like a distributed model for exactly the same thing.
Chaining and all of that stuff, and people keep using the blockchain word everywhere, and it kind of looks like one, but not really at the same time.
Yeah.
But
right.
So a little bit different, but the same ideas in general. So.
And so like one thing like that I sort of haven't been able to wrap my head around yet is like I get the basically like storing provenance metadata, build provenance metadata, and like attestations, adjacent to the artifacts that they are related to, right? A has the benefit of you only have to authenticate with one system, right? I think that's particularly important in the context of like a Kubernetes admission controller, right? Because you don't want to have to establish trust with a separate API to get that information, but B, it's just much more convenient to use the same tooling for both, right?
It's convenience, availability. If you copy stuff around, a lot of people do that, like take things into an air-gapped environment, all those reasons.
Right. But like, I guess one thing I haven't seen like a missing piece for me is like, where do we store and how do we interface with like vulnerability report data, right? Like if I scan a container image and I have a list of known CVEs of various severity, like how can I store that in a way that is easy to interact with and generate attestations for, um, but also like ideally I would do so in an efficient way that makes it so that I don't have to constantly like rescan the same artifact or image layer, and I can have like a more robust solution around like when my CVE database gets updated, like I don't have to rescan the universe, right?
Right.
I can have like a more tailored approach, I guess.
Yeah, the Sift and Gripe tools from Anchor are pretty good. If you've seen those, they don't go the whole way of doing the attestation stuff, but they, they're decoupled. So like, there's one thing that scans and generates an SBOM, and that's just a text file now, and that's what you can use to query a database later. So you don't have to keep going over the image layers and everything like that. It's
Uh-huh.
SYFT and GRYPE.
Okay.
I like them. Yeah, you're kind of missing the attestation piece of it, and I think I've thought about that. I think I've written a blog post or two, but yeah, we haven't done it all end to end anywhere. I think that's a case where like the FedRAMP compliance stuff actually kind of makes sense, and what they tell you to do kind of leads to a pretty easy solution. Just nobody's done it yet.
Hmm.
Where like I don't think you want to store the whole scan result or anything like that, and that's not really what you're testing. Really, what you want to attest is that you did a scan and it looked good at a certain date.
Okay.
And that's what FedRAMP requires, and that's what it kind of makes sense anyway. It's like, yeah, we know vulnerabilities change every single day. What you want to know, I mean, and the only thing you can really prove anybody is that it was good when you deployed it. And like the requirements say you have to scan every 15 days, 60 days, something like that. I can't remember. And so that kind of looks like an attestation with an expiration timestamp on it.
Right.
And so that's kind of the type of thing that could go into a policy engine. Not the giant list of all the vulnerabilities you saw, just that there were none that exceeded some threshold as of this date, and that is now good for 15 days or 60 days or something like that.
Okay. Yeah, that makes a lot of sense to me. I guess what I was thinking is that like part of what was appealing to me about making, like the Kubernetes cluster, for example, the policy enforcement
Yeah.
point is that it like provides you a bit more flexibility in making that determination, right? You mentioned like expiration
Yeah.
time as one example, but it seems to me that like even like what level of vulnerability you might be willing to admit
Mhm.
into like a development environment as
Yeah.
opposed to or even like an environment that you're intentionally trying to like reproduce
Mhm.
like a vulnerability in would
Yeah.
be the barrier would be significantly lower there than in your production environment, right?
Right.
And so like it seemed to me that like if you don't capture that full set that full vulnerability list, then you sort of limit what you can do on the deployment side. But I
The
don't know how big of a deal that is in reality.
Yes and no. I think you still kind of have to flip it around a little bit. Like one of the threats you kind of have to worry about a lot is like, what if somebody just deletes an attestation, or if you lose it in transit somewhere or something like that? And so,
Yeah.
like, you kind of don't want to attest to the presence of vulnerabilities. Like, you wouldn't want to attest to this is the report.
Uh-huh.
You kind of want to, because then if like you just delete that attestation, now there are no vulnerabilities, kind of thing. It's like, oh,
Right.
cool, there like none showed up here, and it's a pretty easy mistake to make. So instead, you kind of want to flip it around and say like, you might still keep around the list that you saw, but really what you want to have is a positive statement that there was nothing that was out of your threshold. Because that way,
Okay.
if that gets deleted, then the thing can't run. Does that make sense?
Right. Yeah,
Like,
totally.
yeah. So you could have both, but you need the one that says this met my policy, and it could be a different policy for development and production.
Right.
But you don't want to just say, here's a list of all the vulnerabilities and sign that.
Yeah.
Because it's like just a little bit inverted.
Yeah, that makes sense.
So yeah.
And I guess a related question is like, have you seen like any like standard metadata formats or anything like that around like
There's one for vulnerability. I mean, there's the whole SBOM thing, which is a mess, and there's like a million different formats now and everything. But
right.
there's one around structured scan results. I don't think it does a ton of adoption. We were just looking at this SARIF, SARIF, like structured static analysis reports or something like that. And if you think about it, a vulnerability scan kind of does look like a static analysis.
Okay, yeah.
Yeah, that the sifting gripe stuff is otherwise the closest I've seen.
Okay, and it was grep GRYP.
GRYPE.
Okay.
Yeah, from Anchor, ANCHORE.
Cool. I'll look those up
Yeah.
later.
Yeah, I do have to switch to another one. We should do
Yeah.
this call again though.
Absolutely.
Yeah.
Really appreciate it. Thank you.
Yeah. Thanks a lot. Have a good day.
Have a good one.
See you.